Okay, so now that you have looked at the entire radical unit, we're going to do a little review. I'm also going to give you some basic definitions, which could have either come first or last, but now that you understand radical numbers, we are going to talk about the definitions. So there are two major kinds of real numbers: rational and irrational numbers. Excuse me. So a rational number, those are numbers that can be written as a fraction. They are numbers with decimals that repeat or terminate, and they can be written as a fraction. So they are numbers like, I'm going to put them up here, even like the number 5. That is a terminating number, 5.0 if you want, and it can be written as a fraction. We can also make it negative. It's totally fine, positive and negative numbers. So all of our whole numbers are integers, check, they're done. Same thing with 0. 0 over 1, totally fine. But now let's get into those fractions. So now, or decimals, 0.5. 0.5 is a terminating decimal, and you can also write it as a fraction, 1/2. Another decimal that you are familiar with is this repeating one, this 0.3333. Well, that is 1/3, right? If you do 1 divided by 3 in the calculator, it's 0.333, and it goes on forever. All of these numbers that can be written as a fraction, the decimals repeat or they terminate, these guys are rational numbers. So now we're kind of thinking, well, what numbers are left? Because that kind of covers all of them. Well, the irrational numbers are numbers that are not rational. So it's all of the other ones. So it's basically ones that have decimals that do not repeat. And they go on forever and ever. That looks like replete, but it is R-E-P-E-A-T. Okay. Those are the decimals that go on forever and ever and ever. And of course, the most famous example of that is pi. Pi is an irrational number, but all of these radicals, and of course they're the radicals that you cannot do, all of these have decimals that go on forever and ever and ever, and they don't repeat. If you type radical 3 in the calculator, it just kind of keeps going. Same thing with radical 15, radical 20. Those are all irrational numbers. Here's the thing. Radical 20 is a radical that you can simplify. Can you do it real quick in your head? 4, 5, so that's 2, radical 5. But even when you simplify it, the radical doesn't go away. There still is a radical in the number, so that's why it is still an irrational number. Don't get fooled if we give you numbers that look like this, like radical 9. Well, that can be simplified, and that's just 3. And square root of 1 over 25, well, the square root of the numerator over the square root of the denominator, that guy's equal to 1/5. So sometimes we're given radicals, but we can simplify them so that the radical goes away, and those would not be irrational. Those are not irrational because these go back to our rational definition, right? We got rid of the radical. But when you simplify and you keep the radical, well, that's still irrational. Okay, so that's it. So simplify your number. If there's a radical in there, or pi, it's irrational, and that's it. So there may be a question on your assessment like this, but the definition is given to you. Just remember, if you see numbers that are in radicals, simplify them if you can first. Sometimes you simplify, the radical goes away. Sometimes radical 20, not so much. All right, let's do a couple of these examples, and let's see if we can do this kind of in fast forward. Radical 90. So hopefully you see this as 9 times 10, square root of 9, 3, radical 10. Next section, adding and subtracting. So we're going to be combining like radicals. If you didn't get a chance to do these, you can pause, but I'm just going to kind of go through them quickly. Here are my like radicals. I'm going to put a 1 in front of that so it helps me. This is kind of fuzzy to me. So 1 minus 3, well, that's negative 2 radical 3 plus 2 radical 5. And it doesn't matter which term you put first, but make sure that negative goes there. Radical 72. Can you do that one quick in your head? Well, that's 36 times 2, so that's 6 radical 2 plus 88. 4 times 22. I think 4 is my biggest number, so that would be square root of 2. This is going to look like 2 times 2 radical 22, right? Square root of 4 is 2. Combine that together, 6 radical 2. That's going to be 422 when you multiply. Minus, well, radical 50 is going to be 25 times 2, so that's 3 times 5 radical 2, and that's going to be 15 radical 2. So now I have to look for some like terms, and I see them here and here. So I'm going to combine those, and I have 6 minus 15. 6 minus 15 gives me negative 9 radical 2 plus 4 radical 22. Okay, hopefully we got the same answers there. Now we're going to move on to these guys here. When you multiply, remember, you're going to multiply outside numbers, multiply the inside numbers. Let's go for it. The outside number, okay, coefficients. The inside number, radicand. You can use those fancy words if you want. I go outside, inside. Okay. Outside number, inside number, and that's going to give me, I don't know, 80, 96. So I'm going to simplify this guy, and it goes into 96. 96 is going to be, let's see. So this is what I would do in my calculator. I would try 96 and I would divide it by some of those perfect squares. I know 81 is a no, 64 is a no, keep going, 25 is a no, 36, nope. Divided by 16, there it is, 16 times 6. And square root of 16 is 4, 2 times 4 is 8 radical 6. The second way you could have done that was you could have simplified first. Simplifying first sometimes makes it a little easier with your numbers. Radical 12 is 2 radical 3. Radical 8 is 2 radical 2. That's going to give me a 4 radical 2. Multiply your outside numbers, 8. Multiply your inside numbers, and you get 6. Okay, so then we move on. Let's do this guy. So we multiply our outside numbers, 2 inside numbers, radical 6, plus, there are no outside numbers, inside number, radical 18. Well, they're not like terms, but if I can simplify anymore, I have to simplify, even if we're not going to be able to combine them. That's 2 radical 16 plus radical 18. Can you do it real quick in your head? Hopefully. Okay, 9 times 2. Okay, so now we're going to do this guy here. So let's multiply him. I'm going to have to distribute. 4, positive times a negative, 2 radical 6, plus 2 radical 6. Positive times a negative is minus square root of 36. Let's simplify. Well, that's a 4. This is the same thing, so that cancels out. Minus square root of 36 is 6, and 4 minus 6, well, that's negative 2. Now I'm going to look at my division guys down here. Problem is the radical in the denominator, and I can't do any simplifying with the first ones. I can with the last one, but I'm not there yet, so let's see. So now I have to figure out how to get rid of this denominator. I'm going to multiply by itself on the top and the bottom. That allows me to just pull out the 3, and on top I'm just going to multiply outsides, insides, and that's it. 2 radical 3 over 3, done. This next guy here, I can't do any simplifying because I can't simplify those guys, not an outside and an inside. So I'm going to multiply top and bottom by radical 6. Multiply here, that's square root of 36, which is 6, but we know just pull out one of the numbers, and that's 8 radical 6. Now I always have to look to see if I can simplify, and I can. So the outside numbers can both reduce by 2, 4 radical 6 over 3. Last ones. Outside numbers, inside numbers, I'm definitely going to reduce here. So this will become 4 over 1, and here that's square root of 1 over the square root of 3. Well, that's just 1, right? So let's just make this 4 over radical 3. Now I have to simplify, radical 3, and that's going to become 4 radical 3 over, pull out one of these guys, 3. If you chose to rationalize beforehand, you can do times the radical 6. It's more work. I wouldn't do it that way. So definitely reduce wherever you can and then rationalize with that number. You're going to do great.